that should be good.
Cool.
Michael, can you say something?
Say something. Are we going straight off?
Oh yeah, one more question. Do you have any audio in your presentation?
No, and if there is, I don't want it to come out because it will just be.
That would be it.
There is demos, but yeah, hopefully they just play.
Hello.
You're good.
All right, everyone. If you can see that presentation, you can tell that Michael's really into Fantastic Beasts and where to find them and the series. Can you tell us a little bit about that?
That's it. That's if there's any trademark, that wasn't the case, and Marino said that and not me.
All right, welcome. Please give a round to Michael. He's going to give us some great information and insights around data management and secrets around them. So take care. Thanks, everyone.
Awesome. Cool, yeah, I did go a little bit overboard with the finding fonts. Whenever you're finding fonts to put into your PowerPoint presentation, you probably know that you've gone maybe a little bit too far. But yeah, what I wanted to kind of touch on, and this was a massive theme over KubeCon, around storage and data on Kubernetes and how the contrast between this year's KubeCon in Amsterdam to Detroit and then back round to Valencia and then back round to North America last year, there's been a constant growth of people putting some sort of storage or data or persistence within Kubernetes. So I wanted to kind of highlight some of those native features within Kubernetes that gives us the ability to, whether it be protect that data, expand what that persistent volume looks like, and some other cool stuff in there. And then I'm going to touch on some open source stuff that we create and we build, or maintain, that just hit the easy button or hit an easier button when it comes to data management within Kubernetes. So before I kick off, I'm Michael Cade. I work at Veeam Software. I focus on Kasten, so you've seen Kasten, we're pretty much the logos everywhere it seems. And we're really focused around data protection and mobility of that data across your different Kubernetes environments. So think about data services, databases that are seemingly ending up inside of Kubernetes, but also think about that application that leverages data that maybe sits in AWS RDS. Because generally speaking, yes, Kubernetes maybe started out life as a stateless platform, and I'll get into like how that evolution has changed and the history around that. But people are running, there's very few completely stateless applications out there, right? They rely on some sort of database or data somewhere. It might not be in Kubernetes, it might be on a virtual machine, it might be in a PaaS-based solution, but there's some data somewhere, and that data is generally maybe a little bit important that we need to think of. Okay, so that's what we're going to cover around here. My massive disclaimer, if Marino is actually recording this, is there's no affiliation. I'm waiting. I don't want to abuse any of the rights, but it was a good session that I did in 2018 about something different, and it went down really well. So I wanted to use that same theme in this session, and Marino and his team, they accepted it, so here we are. So things that we're going to uncover, and I'll stop using this font shortly so that you can actually read the slides, but I want to get my money's worth. No, it was free anyway. But Kubernetes storage and the building blocks around it. So what is Kubernetes storage, or Kubernetes? Julia mentioned it if you were in the session before. Kubernetes is complex, right? There's no getting around that. We are making it better, I feel, as a community. We're making it more accessible. We're making everything a little bit easier around it, but there's no easy button for Kubernetes just yet. And then you've got networking, you've got storage, you've got everything around that. There's complexities on complexities. So we'll touch on the building blocks. Where there's storage, there's generally data, and if not, then I don't really know what the scenario is. Data services in Kubernetes, and I'll maybe try and touch on some of that data services outside of Kubernetes as well if we've got time. Actually, yeah. We're going to build something in a demo. then let's look at what we have at the native capabilities around being able to protect those workloads within Kubernetes. Let's say we've decided to put Postgres inside our Kubernetes environment. How do we protect it? Bad things happen. I guess in the news we see about things like ransomware and really bad things, but I know it's very easy to drop a database. In fact, I'll show you all how easy it is. Data outside of Kubernetes, yeah, I thought I did list that. And then open source options. How do we hit the easy button to all of this complexity when it comes to just a small little area of data management within Kubernetes? Okay, so what happens if you don't have any persistence? Hopefully this auto plays. So what if I was to create a database? So let's say I've got a config map, I've got a stateful set, and I have maybe a secret. And that stateful set is going to deploy Postgres in there. Hopefully you can see that. It's a bit small, probably at the back. But ultimately, config map that gives me information about how do I get to my database. Stateful set, this is the Postgres pod that I'm going to deploy, and I only want one of them, but this obviously can be scaled out accordingly. And then I've got a service that allows me to connect into said Postgres database. Notice I don't have any persistent volume claims or any sort of storage within that. So I guess before we get to the end of the demo, you can kind of guess what's going to happen. I'm going to add some data to a database because I have Postgres, it's in the container. But guess what's going to happen when I delete that pod? It's going to get back to its desired state, it's going to redeploy a new container, and we're going to jump back in and, spoiler alert, the data is going to be gone. So that then leads us on to, okay, so if we decide to put databases or data services within our Kubernetes clusters, then we need to consider how do we do that using enterprise storage, giving us resiliency and HA to that, but equally how do we make sure then, how do we protect that from accidental deletion and all the other failure scenarios when it comes to data. So here we go, I've added a new table into my database. Now we're going to delete that pod, and yeah, we're going to spin up a new one, and that table is not going to be there. So that's why we need that PVC, and I did obviously some real good meme work on a GitHub pull request on unable to create data services with no persistent storage. So let's quickly jump into that and just show. I've already told you the outcome, so the spoiler has already happened. But yeah, there's /DT on that. Yeah, we don't have any. Okay, so from a script point of view, to keep on the theme of film, Kubernetes wasn't designed to handle stateful applications. Yeah, okay, probably wasn't when it first started. I think we can all probably say that, all vouch for that. That doesn't mean that things can't evolve into having that capability and that functionality in there. Now from data on Kubernetes, so a smaller community within the Kubernetes environment, Kubernetes community within a community. 76% of the 500 Kubernetes users that they asked now use some sort of database or data service within Kubernetes. So that's quite a considerable amount, right, of that 500 people. But why? So consistent management between application and data, same infrastructure, same tools. So thinking about what that looks like. The evolution of Kubernetes, we're making it easier. Features and functionality are coming out in every single release. There is no reason why storage and data within that cannot be a first-class citizen within Kubernetes. Okay, scrap some of the text so you can read them. However, there's far too much text on here, so I'm just going to touch on the building blocks of Kubernetes storage for those that are not familiar with it. So if you think about the storage layer, and I come from an infrastructure background, an operations background, a storage administrator from NetApp Storage, and it's easier to explain this to the storage admin maybe more so than a developer, but maybe we can work backwards. Maybe we can get there in the end. But if we think about a persistent volume, I've gone onto the storage array that I'm going to use for my shared storage solution that brings me high availability, it gives me resilience. I have this external storage, NetApp, let's say, no affiliation there either, but some sort of shared storage, and we create something called a LUN or an NFS export, and that's going to be our persistent volume claim. We're going to enable that within Kubernetes, and then on top of that, we're then going to, our application and I'm not going to get into dynamic versus static, but there are different ways in which we can claim this persistent volume claim. But persistent volume claim is the application comes in, I want X amount of storage, and it goes and finds that persistent volume and goes, yeah, you can go and sit on that one, great stuff, go and sit there, we'll use some of that up. And that becomes where we're going to potentially put our database, for example. And then we've got this different tiered way of being able to understand what the different storage options that we have. Maybe you do have a NetApp, maybe you have an NFS, shared NFS server within your environment. Maybe you have some really fast disks, some really slow disks, and some medium disks, some gold, silver, bronze type thing going on. And it could be speed, it could just be functionality within that storage. So these are defined in Kubernetes as storage classes. So maybe for my database, I want really fast storage, but maybe for unstructured data, for photos, for my home drives within my infrastructure, that can just be bronze tier. I don't really need that to be very quick. So we define that through storage classes within our cluster. Okay, then how do these piece together? How can we talk to each other from this? So before, I would say 2020 is before CSI, for example. CSI, actually, let's start there. CSI gives us the opportunity for storage vendors across the ecosystem to develop and provide storage capabilities out of band that just tie into CSI. CSI is a group of capabilities that are exposed on every Kubernetes release since, I want to say 1.21, maybe 1.19. As far back as that, at least from an alpha point of view. And it just means that the storage vendors don't have to wait for Kubernetes to release to be able to have functionality within that. So the CSI makes it easier for enterprise storage to deliver that storage class or that type of storage to the Kubernetes environments across the board. And you'll see CSIs from all the big public cloud providers, but also enterprise storage systems, Pure Storage, NetApp, Dell EMC, you name it, they've probably got something going on in this world. Now, pre-CSI, it was all about in-tree, and I didn't even include it as around flex volumes, but in-tree was in-tree. We had to wait for storage vendors to wait for PRs to be approved over the whole Kubernetes release. So you can imagine trying to just get simple functionality in, it was slowing things down, or it just wouldn't get in. So it would take a lot longer to get functionality. So the CSI was born, which just, in fact, the next one will provide what that is. So if you think about the Kubernetes release, it has a CSI functionality, and then the storage company writes against that, plugs into that, and says, right, I'm going to take XYZ functionality and I'm going to leverage that within our storage. Things like volume snapshots, things like volume expand, all of those functionality come part of that CSI driver. And ultimately, without going into all of the details on there, because I know I've got demos to show as well, this is the workflow of how that is communicated through the nodes, through the control plane, and then finally, from your application point of view, you get high availability, you get resilience for your underpinning storage for your data services. Stateful sets, so one of the things that you would have seen where we used a stateful set versus a deployment is it was Postgres -0 versus Postgres blah, 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 like random UUID thereafter. So deployment doesn't really care. It's just going to deploy, if you say I want 5 different pods, it's going to deploy them, random names, and when they get deleted, it's just going to deploy another 5 random names or however many you delete. With a stateful set, it's a little bit different. So what it's going to do is, with that 0 or that ordinance, that 0, the 1, the 2, it's going to be more methodical around how we refresh those. So if we delete 0, it's going to bring that back. If we delete all of them, it's going to bring 0 back first, then 1, then 2. And that's what's going to give us that maybe closer to a traditional pet type environment. I'm not going to get into pets versus cattle again here, but it's a little bit more control when it comes to shared storage, because we can't just have multiple pods being spun up and things taking ownership of storage. So it needs to be a little bit more methodical in how it works, and that's going to give us stable storage, which if anyone works with databases in the room, you know that you need stable storage. I need it to self-heal if something bad happens to one of those pods, and I need to be able to update those as and when my application changes or my database application updates. I thought I hid these. Basically what I just said, that kind of relays into this. Okay, so let's get into some of the features and functionality around that. So one of the more recent, and in fact that's quite an interesting fact on. If you look back over the last 3 or 4 releases, maybe even 5 releases of Kubernetes, bearing in mind there's 3 releases a year, over the last 2 years we've seen something around storage in that release train. And I think that's testament to that 76% that we saw mentioned from a data on Kubernetes, which by all account, their survey is very niche into a group of people that are running data on Kubernetes, or people that are interested in that. So maybe that number is not reflective of the whole CNCF. But if we look at the CNCF surveys as well, they aren't too far off and a much bigger end number in terms of how many people they've used. So there is a massive trend towards data being ran within Kubernetes and taking advantage of that. And we're seeing different scenarios. One is the outside of Kubernetes that I mentioned before, is that using AWS RDS or different PaaS-based solutions, people running it side by side within their application, database and application running next to each other inside the same, even inside the same namespace within their Kubernetes cluster. And then equally having a dedicated Kubernetes cluster that is just there for databases or data services, and then you have other clusters for your application. So there's a lot of freedom of choice when it comes to Kubernetes. Anyway, back to this, Kubernetes 1.24, so I'm not just going to talk about data protection, but if you think you've deployed a persistent volume claim and it was 100 gig because it needed to be 100 gig, but now I've grown, maybe I've inherited another customer base, another bit of data, maybe even acquired another company, I need to expand that. It needs to be a terabyte. It needs to be bigger. So up until 1.24, or pre 1.24, I didn't have the capability of being able to expand that. We would have to do basically a copy and paste by all accounts. We'd have to build our new terabyte PVC, and we'd have to copy and paste everything over, and we'd have to remap everything. Well, that means the database goes down for at least a little bit. This is dynamic. This allows us to do it on the fly. Now, this is stuff that we had in virtualization, we have in cloud. We had that years ago. So to see this come in is an evolution, again, of how storage is being seen within the Kubernetes community. Okay, so I've spoken a lot about data storage. So let's think about that as well. And I also mentioned around high availability and like fault tolerance, making sure that if one pod goes down, I need that database to stay alive. So maybe I've got multiple pods that are looking at this storage and we can load balance across and all of that good stuff. Resilience, massively important part of that data management story, 100%. But what happens if I go into my database, like I just did, and instead of adding data, I delete or I drop the database or I manipulate that data in some way? Kubernetes has no idea about that. Like if I've got my desired state, I've got all my pods up and running, I've got my services, I've got my config maps, I've got everything. The control plane knows nothing about that. So we have to think about, and this probably is more over to the SRE side of the fence rather than the developer or the DevOps or whatever your team, whoever has the data responsibility. This is where we have to start thinking about, okay, how do we make this available under all or any circumstance? When I'm talking about data protection, sometimes I start talking about like fire, flood, and blood and real gory bad things, right? You can add ransomware because it rhymes, right? If you fire, flood, blood, ransomware. No, it doesn't. But I talk about bad things, but we all know that accidental deletion, accidental problems always happen as well. And Kubernetes is just another platform. So we look after virtual machines, we look after cloud workloads, etc. So what is enough? What level of protection is enough? Is just having a copy of that in a read-only state in another Kubernetes cluster, is that enough? Like, is it replicating changes on the hour every hour? So if you made a bad change, would it replicate that bad change? I don't know what the answer is to your application, but data protection workflows can become very complex. You have to understand what that looks like. So let's now have a look at, well, okay, first place to start is what do you have natively? What can we do within Kubernetes to help us protect that workload? So the first thing is around volume snapshots. Again, I'll make a copy of these slides available to everyone so you don't have to read that or everything on there, but basically what this allows us to do is snapshot our persistent volume claims. So if you think about that Postgres database, volume claim, where our data is going to be, our mission critical data potentially, this allows us to take a snapshot. Now that's going to be a manual way of being able to do it. I mean, you can create cron jobs and you can do all of that good stuff, but it gives us the ability to start the ball rolling when it comes to, okay, before I make a big change, let's take a snapshot. It'll be in a crash consistent state, but ultimately let's just walk through what that looks like. So we've got our pod simplified. We have one pod, Postgres 0, for example. We have a PVC, and we have a persistent volume claim. Everything I've just touched on, and that'll be based on a storage class as well. Oh yeah, there it is. And this source is from a volume snapshot. We then create that volume snapshot class, and we store that as a volume snapshot content. This is where that storage vendor has decided whether they link up to that. So not every storage that has a CSI driver has the ability to leverage volume snapshot classes. There has to be the storage vendor will have to have added that into their version, into their CSI driver themselves. Okay, let's look at what a volume snapshot actually looks like. So native into Kubernetes, hopefully that.
You can see.
Yeah. So we're going to create a volume snapshot. So I'm not using any other tool, I'm just using my Kubernetes cluster, and we're going to just show what that looks like. So let's see what volume snapshot class is. So I'm using a host path. I think this is using Minikube. Host path are a completely different story. I should do a whole session on that. If you're going to run any persistent volume in any anger, don't use the host path. That's my only advice from this. It's good for demos though. So let's create a pod and a volume snapshot in the volume snapshot demo. I keep hitting the mic. So you see down here we've created a volume snapshot namespace, we've created a persistent volume, we've created a pod. Now we're going to watch that just suddenly come up, yep, very quickly. This is very simple, it's not even a database, it's just simply a pod that is going to connect to a persistent volume claim, and we're going to put a file in there. That's literally all we're going to show here. Okay, so our pod is up and running. We're now going to dive into our pod. And we're just going to create a file called index.html. Obviously, I'm sure no one will delete this. But simulate that, like even yeah. So there's our file. So you'll see here as well that we have no volume snapshot. In fact, yeah, because in fact I should have checked that against the namespace. Do I do that now? Can't remember past me. I only looked at this an hour ago. Anyway, we're going to create a snapshot. So what that is specifying what persistent volume claim we're going to snapshot, and you can see here that we created that. And now if we go and look at what that snapshot is within that namespace, because I've now actually put the right command in, you can see that 10 seconds ago I created a CSI snapshot called snap content. So I have a snapshot of my mission critical index.html and the PVC amongst that. I don't know anything about the whole application, but I know about that volume. So, okay, do I cause a problem here first? Yeah, let's jump in. Obviously, past me was feeling a bit hackerish and was like, let's go. And let's go and delete our, okay, yeah, so we've deleted our index.html, severe catastrophe. And what we're going to do now is we're obviously going to use that volume snapshot to restore that. Now, this could be, if you're only running one application with one persistent volume claim on your Kubernetes cluster, this might be enough. Like, you just run this as a cron job every night. I've got loads of snapshots, brilliant. And that might give you enough resilience or enough recovery options if something bad was to happen. I would argue, though, that you're probably not going to have just one persistent volume claim or one data service. You're probably going to have many. So we have to think about, okay, how do we streamline this? How can we orchestrate this? Then you can start bringing in the actual data service. And what does that look like as well? Because databases don't like that yanking the power cord. Like, if you don't speak to the database and say, I'm going to take a snapshot, they don't like it when you bring them back always. Like, there's a big asterisk there to say, we probably have to tell the data service that we're going to take some sort of backup. Okay, what I was doing in the background, I was running that recovery, so you now see that we've logged back in, we've used that volume snapshot, and we've got our indexed HTML back. What we can also do with that, and this also lands in that data management bucket, is being able to clone it. So as much as I just did a restore, what about taking a copy of that data multiple times and using that volume snapshot as the source to that? Now that can be quite interesting, especially if you're working in ML, AI, and you've got a model that you want to test against a certain data set. This gives us the opportunity to take that source PVC and expose that out several times to our model and understand something from that. Obviously, natively it knows nothing about your model or your data, but it gives you the opportunity to run that clone. And this is all native as well. It's already included in your Kubernetes distribution. Okay, so I mentioned around databases need a little bit of love and care when it comes to protecting or backing up. And we have an open source project called canister.io, and this is focused on diving inside of the database pods and being able to leverage native tools within that database or data service to be able to take a consistent copy of that data. Now, I could do a whole session on consistency and what that means, but going back to the analogy of database servers, when they're in physical, if you just pulled the power cable out, put it back in, it probably won't like coming back up. It won't be, I mean, we're a lot better than we were. There's a lot more resilience when it comes to databases, but I wouldn't risk probably the most important data in my company with that. So what this allows us to do is dive into the application. So just to, again, I'll make sure that these are available afterwards. So Canister, as an open source tool, Helm chart deployment, deploys 3 CRDs, action sets, blueprints, profiles inside its own namespace. In this instance, I'm using Elastic. I've spoken far too much about Postgres so far, and other databases are available. And Canister lives within its own namespace. Elastic has a pod, a PVC, a stateful set in its own namespace. And what we're going to do actually is we're going to take a consistent backup using Elastic Dump. We're going to send it to our min.io as well as a snapshot locally. But really the important part here is that this min.io, don't tell anyone, like this min.io still runs on that same Kubernetes cluster. For demo purposes, I would always advise this should be as out of the production environment. Like this should be an off Kubernetes cluster or off. It should be an AWS S3 bucket away from your cluster. So that's what we're going to do. So yeah, data consistency or application consistency. Okay, mouse is moving. I don't have much time. Okay, so past me hasn't deployed Canister. Cool, so now I know where we are. But I have deployed min.io. Again, caveat, don't do this. Don't back up your stuff to the same cluster. If your cluster dies, bad things will happen. Well, you won't have any restores. So I've added the Canister Helm repo. So I'm just going to install that into its own namespace using some basic default chart values to that, as an operator to that, blah, blah, blah. Okay, yeah, let's fast forward that. Get the pods, they don't take very long. Cool. Okay, so the next thing I want to show is they're the 3 CRDs that I mentioned. So an action set this is an instruction. This is what I want you to do. Blueprints are, this is a desired state of how I would interact with a native tool like Elastic Dump or PG Dump or MySQL's version, etc. And then location profile is that min.io S3 bucket, or it could be an NFS export as well. Okay, so I've created a S3 bucket or a location profile using that CRD. So this means I've now got somewhere to send my backup or my TGZ file, for example. And I also have a blueprint here. So the blueprint is going to define, and I like to describe this as a if this then that type scenario. So this is going to say, I want to dive into your Elasticsearch pod, or alongside it, I want access to it. I want to be able to then trigger Elastic Dump, and I want to send it to that new location profile. Okay, so we've got the blueprint, we annotate that, we push that against our deployment or stateful set within that Elasticsearch namespace, and then we use our action set to trigger that. And again, going back to where we were before with the volume snapshots, which we can create cron jobs for and have a schedule around that, we could obviously schedule that action set to happen on a daily, hourly basis. So this is me putting some data into my Elasticsearch. I'm not sure. You're just going to have to trust me if you can't see it. That we're going to delete some data and put some data back. Generally, the way my demos go is good thing, bad thing, we're going to get back to a good thing. So let's protect that application. So you saw that we had some good data. Trust me, that was really good data, mission critical data. And now we're going to get the profile. So there's our profile, S3 profile. That relates to that min.io bucket. Again, I've got sessions on Canister going into a deeper dive of that. So we're going to define that through some environmental variables just to make it easier. We're going to use CanCTL, which think of CanCTL as a CLI tool for Canister, and that's going to allow us to define what that action set looks like. You can see here that we're going to use this stateful set that is in ES test, which is the Elasticsearch namespace. And you can see here when we've ran that, it's now run. You can see that it's complete as a state. And you'll see if we go into the bucket, into ES test, into master, there's our compressed file, and that's going to contain our good data for that. Conscious of time.
You got -1 minute.
Cool, let's go. But so disaster strikes, something bad happens, and oh no, yeah, let me have this time to show it. And now I'm going to go in, I'm going to do some bad things to my data. Delete, you see delete there, that's bad. No one, that's bad, real bad. So obviously we need to go to our backup. We need to go to that GZ file that is now in our min.io on the same cluster. That I probably shouldn't have told you that. I should have probably told you that that was in a different location, or adhering to the 3-2. No, we don't need to get into 3-2-1 rules and stuff like that as well. Okay, let's restore the application. So this is another action set. So an action set is not only a backup action, but it's also a restore action, and we can have a delete action as well in there. But ultimately, again, it comes down to an if this, then that. So we define what that backup action needs to, or that restore action needs to look like, and then we can leverage that and restore and get our data back to where it was. So we can see what our name is. So that should be done pretty much straight away. You see that the action set was created, the restore, backup. So if I think we should probably exec into that. Oh no, look, yeah, there it is, it's finished, complete, 10%? No, 100% it means. Pull request welcome for our open source project. Now exec into it. Show all of that good data that we've recovered. It's obviously thinking about it. Past me was like, how do we cube exec? Yeah, okay, copied and paste it. Okay, we're in it. We're going to see some data. It looks like data. I don't know if it's the same data, hopefully. Okay, that looks like, if we had two comparisons, that looks like what we had before.
Demo work?
There you go, yeah, it worked. I think that's it, yeah. Two more things, so volume health monitoring. Yeah, I'll send the slides. That's just another new feature that's come again, something else focused on storage within Kubernetes. Go and speak to everyone out there. I'll be out there as well. So I've showed you what is natively available within Kubernetes, and if that works, great. Just consider that from a data protection point of view. If you need application consistency, then look at that open source tool. If you need that to be even more orchestrated and more enterprise grade hardened, then K10 gives us a little nicer way of being able to protect that, but whilst also being able to give us a lot more functionality when it comes to mobility of data as well. Okay. Last reference to the film that is nothing to do with this presentation, but yeah, any questions, let us know, but I know I'm holding you back from lunch, so yeah, thank you very much for sticking around. Thank you.